For most people, it's difficult to comprehend just how much the human condition is set to be transformed over the next few centuries. So much so that when considering the level of change that's poised to transpire, it seems somewhat erroneous to refer to this future as human at all. The dramatic intelligence and sensory augmentations that advanced neurotech will eventually allow for have the capacity to reshape every aspect of how we consciously experience reality in ways that could eventually be as disparate to our current cognitive and sensorial perception of it as ours is to other animals and primates. In this video, I'll focus on the far future of humans, the nature of reality, and how BCIs and neural technology can eventually broaden the limited range to which we currently perceive it. This video will expand upon many of the topics I covered in a previous video I made, which I'd recommend you check out before watching this if you haven't already, as it serves as a frame of reference for much of the subject matter I'll discuss here. As always, please like and subscribe if you enjoy this type of content, and without further ado, let's begin. In the last video I made on the topic of human augmentation technologies, I discussed how future BCI tech will eventually allow us to exert full control over how our brains process sensory information, and let us manipulate the human perceptual system at our will. Eventually, however, these capabilities could expand far beyond over having full control of our senses, and ultimately even extend to enhancing their baseline functionalities, letting us fundamentally overhaul the reality we perceive by default, rather than merely augment it. Though before I continue, it's first worth asking, what is reality? In its most basic sense, it is simply the most likely reconstruction of our brain's interpretation of its surroundings, which occurs as a result of the way our sensory organs have evolved to process perceptual information via external stimuli. With this in mind, it's easy to understand why other organisms whose evolution followed an entirely different trajectory happen to see, hear, and feel things differently than humans. For example, as a result of the way that canines have evolved, their eyes have fewer cones than ours, which are a type of photoreceptor cell that enables color vision. The consequence of this being is that humans perceive a broader spectrum of color than dogs do, which allows us to take in a richer view of our environment. Another advantage that this higher density of cones allows for is better visual acuity, 20/20 to 20/75 to be exact, meaning dogs have to be roughly 20 feet away from something to see it in as much detail as humans can at 75 feet. Despite these shortcomings, dogs compensate for them in other respects, such as better low-light vision and motion detection, which aligns with their evolutionary adaptations as nocturnal hunters and scavengers. They also have a larger field of vision, significantly more sensitive hearing, and a much more detailed sense of smell than we do. These types of evolutionary trade-offs hold true across the entire animal kingdom. I illustrate this to elucidate that the way humans perceive the world is no more or less real than any other animal, but is simply a consequence of the level of detail that our sensory organs can perceive, and that which our brains formalize reality through. Bearing this in mind, regardless of what a base reality actually looks like, or if it's anything that could even be perceived at all, it's obvious that current humans experience it through a very narrow scope, which could be greatly expanded upon with the type of advanced neurotech that I mentioned in my last video. This is because once we can substitute the inputs of our real senses with ones that we can generate artificially, the sensory information that we could encode them with won't be limited to the normal range of the human perceptual system, but could deliver heightened sensory signals to the parts of our brains responsible for processing them. Take vision, for instance. There are multiple ways we could use this technology to surpass the normal acuity of human sight, but one of the most straightforward approaches would be to use advanced cameras or sensors to capture visual information of an environment. Such devices could be designed to surpass the natural resolution and sensitivity of the human eye. Once this visual data is captured, algorithms could be implemented to filter specific visual information, which once processed would be encoded into electrical impulses that mimic the language of the brain. This encoded data could then be transmitted directly to the visual cortex, effectively bypassing our natural sensory organs. The capabilities that this would enable could enhance every aspect of the human visual system. For example, it could allow us to see at resolutions far beyond what the human retina can perceive, or let us view colors that are outside of the boundaries of normal human vision, in the same way some colors are already visible to us that are imperceptible to other animals. Via the same process, we could potentially even expand the scope of our field of vision to a full 360 degrees, which some animals like dragonflies already perceive the world through. Obviously, these types of perceptual enhancements could also extend to other senses, and allow for things like an enriched perception of sound beyond our natural auditory range, or let us refine the way our brain perceives tactile sensations, providing a more detailed perception of touch. It could also allow us to create entirely new senses that we're unable to presently conceive. It's worth noting, however, that many of the things that I've listed so far would likely require additional neural modifications beyond simply feeding our brains artificial sensory information, largely due to the fact that they never evolved to make sense of these inputs. As such, this would be much higher hanging fruit than the types of things I discussed in my last video, which would simply involve hijacking the normal sensory information that our brains are already designed to perceive. Which leads to my next point. By the time we can enhance our perceptual system to the degree that I've discussed in this video, it imposes a further question. Since if reality is simply the sum of how our brains interpret sensory information, then by this point, why would we still use our physical bodies and base reality as the mediums through which we process it? It seems likely that by the time we can enhance our baseline sensorial perception of physical reality, we'd abandon it to exist inside one that's entirely virtual, where we could design and perceive sensory inputs that are more complex than any possible interpretation of the ones we receive from the physical world could be. In essence, there's only so many ways we can interpret the sensory information that it generates, as the inputs we take in from base reality are limited by base reality, and we could ultimately inhabit one that's much richer and complex by designing it with a higher level of information output. The second benefit to consciousness and intelligence existing virtually would be the allure of being unbound by the constraints of physical laws, as this would enable the exploration and execution of infinitely more advanced feats than what's achievable within the confines of our base reality. The director of operations at Neuralink, Sivan Zilis, has previously alluded to this, and said, "When we have truly immersive digital worlds, not VR, think 50 generations beyond that, they could eventually become so much more high-dimensional that the physical world becomes less interesting as the main domain for exploration. With something akin to this occurring, its ramifications would reverberate in ways that are hard to imagine or account for. A good illustration of this could be language, as in a reality that much more rich and complex than the one we currently experience, trying to convey things about it with human language could be like monkeys attempting to use animalistic grunts to describe and make sense of human society. Simply put, the form of communication they use doesn't have enough information bandwidth to convey the complexity of the human experience and our civilization as a whole. In a world as different from ours as the one I'm describing, the same would likely hold true, as our current linguistic constructs would fail to capture the intricacies of these heightened digital dimensions. Another consequence of abandoning our base reality for one that's entirely virtual could be the very nature of identity undergoing a paradigm shift, as once we transcend the confines of our physical bodies, questions of self and existence could take on entirely new dimensions. Consider the notion of a digital self, a manifestation of identity that transcends the constraints of a fixed biological form, and is customizable in ways unimaginable within the limitations of the physical world. This begins to open up questions about the persistence of a core authentic self, or if such a concept could even exist in such a reality, since its manifestation would be entirely malleable within these virtual worlds, unbound by the immutable constraints of physics and biology and changeable on a whim. These types of existential questions are central to the conscious experience in a world with such flexible boundaries, where the traditional confines of selfhood could yield to a more expansive understanding of what it means to even be and exist. But one thing's for certain, that the further neurotechnology progresses, the further the boundaries of humanity will commensurately dissolve, which could eventually lead to an era of consciousness beyond the limits of our current comprehension. If you found these topics intriguing, then please hit the like button and subscribe to my channel, as you can expect more thought-provoking content on a wide variety of topics in the future. In the meantime, check out some other videos I made if you haven't already, as some of the subjects they cover include both generative AI and artificial general intelligence, and the future of AR, VR, and brain-computer interfaces, which in some ways this video functions as a sequel to. As always, stay posted and I'll catch you soon.